how to predict the direction of a reactant from the what? Equilibrium, and also what you call the reaction quotient. Okay, so it is observed that observation shows that equilibrium constant is derived from the rates experimentally. Okay, therefore we could observe per time. We can determine the ratio of the concentration of the product. We can determine the ratio of the concentration of the product to that of the reactants per time under non-standard condition. This determination of ratio of the concentration of the product and the reactant is what we call the reaction quotient. Okay, so the reaction quotient equals the equilibrium constant at equilibrium. That is, the reaction quotient equals equilibrium constant at equilibrium condition. Now, if this reaction quotient is less than the equilibrium constant, then the reaction will proceed from the left to the right. So this is how we can predict the direction of equilibrium from the reaction quotient. If this reaction quotient is greater than the equilibrium constant, then the reaction will proceed from the right to the left. Now what I mean, when we say from the left to the right or from the right to the left, picture this: the reactant side is the right hand side. Okay, so as I'm on the board now, this is my left. Okay, this is not how you observe it. You observe it like this. Where is your left? Your left is here, right? This is your left. So your left is the reactant side. Your right is the product side. So a reaction that proceeds from the left to the right is favoring the forward reaction and favoring the product formation. The reaction that is shifting from right to the left is going to the reactant side. Okay, that is favoring the backward reaction. So for the first one, if Q is less than K, it means the reaction will shift from the reactant side to the product side, thereby favoring the forward reaction. If the reaction is shifting from the right to the left for this one, when Q is greater than K, then it means it is going what? Backward, or favoring the what? The reactant formation. So we can predict the direction of equilibrium constant or direction of a reaction using the reaction quotient, which is also in somehow related to the equilibrium constant. So I'm going to look at a simple calculation that can help us understand this thing I've written on the board. So let's look at this question on how prediction of equilibrium or direction of equilibrium constant of a reaction. Okay, so look at this example. The equilibrium constant for the reaction, look at the reaction. Okay, sulfur trioxide or sulfur 4-oxide decomposing to give us sulfur dioxide or sulfur 4-oxide and then oxygen at 1700 Kelvin was found to be, this is the equilibrium constant. Okay, from experiments. Okay, if you have a reaction mixture whose composition is this, predict the direction of this reaction. Okay, for us to predict the direction of this reaction, we must find the reaction quotient. Okay, and the reaction quotient is the ratio of the product of the equilibrium all over the ratio of the what? Reactant. Okay, all over ratio of the reactants raised to the power, raised to their coefficient. Okay, raised to their coefficient. So from this reaction, the product of this reaction is these two things here, right? So what we have here will be the value for SO2. What's the value for this SO2? The value for SO2 is 0.284. Okay, raised to the power of 2. Why is it 2? Because of this 2 that is here. Okay, multiplied by that of oxygen. Oxygen is 0.093. Okay, divided by that of what? Sulfur trioxide or sulfur 6-oxide, which is going to be what? 0.048, all to the power of what? All to the power of 2. So when you solve this expression, you are going to get 3.3. Okay, this is the reaction quotient. Now look at the reaction quotient, look at the equilibrium constant. You will notice that the reaction quotient is less than the equilibrium constant. Okay, and if the reaction quotient is less than the equilibrium constant, if the reaction quotient is less than the equilibrium constant, the reaction will proceed from left to right. So when it goes from left to right, it will be what? It favors the forward reaction. To favor the forward reaction. So this is a simple example on how we can be able to predict the direction of an equilibrium of a reaction from the equilibrium constant and the what? And the reaction quotient.